Our next speaker, he's a bit of a nomad. He's lived all over the country, possibly the world. He did spend a lot of time in Chicago, which apparently ruined him a little bit. You know what they say about economists that come out of University of Chicago? They have a reputation for having really bad taste in what they think is pizza. He doesn't realize how bad that slop is. I'll call it, it's a good casserole, but some people say it's an insult to casserole. But he doesn't know any better. He hasn't spent enough time in the Northeast where the pizza belt is. He's also an economist, right? Do we really trust an economist? They always have on the one hand and the other hand. They use Stata. This economist doesn't use Stata, at least anymore. He uses R. That's how we know him. So a lot of things wrong with him, but a lot of things right with him. Please welcome Jonathan to the stage.
Welcome. I'm really happy to be here. I really miss seeing all of you in person, but I'm really happy to be here. I really love seeing what happens to the R language. Like, I think this is just such a great community. I'm happy to be a part of this. I will talk about explainable machine learning, and explainable machine learning is like a really hot buzzword now, and hopefully we can bound this in some amount of reasonableness. So I think one of the cool things that we do here is we actually have a field experiment in explainable machine learning to see how people actually use this. And working with experimental data, I started looking forward using all of the new Bayes tools. So a subtitle of this could be "How I Learned to Stop Worrying and Love the Bayes with rstanarm." Another subtitle could be, "Dang it, Jared is always right," because it turns out that what Jared told me to do was the right way forward. This is joint work with Selina Carter, who's a PhD student at Carnegie Mellon University. She gave a really great talk on the first half of this at DCR. So if you're curious about that, please click that link. This is really a sequel. So Too Fast, Too Machine Learning, Tokyo Model Drift. Selina talked about building the machine learning model, and I will talk about all the other things we did in order to implement that machine learning model and to figure out if explainable machine learning actually improved anything. All right. So why do we care about explainable AI? And I think one of the big reasons for this is just that as AI takes on more consequential decisions, we might need humans in order to do that type of validation. There have been a lot of prominent examples, and I have to commend people as journalists who have looked into these examples, where we trusted an AI to make consequential decisions, and the AI made an error, and that error impacted someone's life quite severely. There's an example of an inmate. So many states now use AI models in order to learn about when somebody should be released from prison. One of those models, because of data inputting error, kept somebody in jail for much longer than they should have, and only from that inmate comparing like physical examples with another inmate did he realize like what was going on. There's other examples in healthcare settings. So there was a hospital that used a model in order to figure out how to triage different patients. And it was discovered that that model was heavily racially biased. It wasn't because race was used as a predictor within the model, but it was because revenue was used in the model, and expected revenue from a patient tends to be highly correlated with race. So we need our models to be able to tell us why they're making decisions, because maybe we need humans to validate this. Another reason is that models are just black boxes. And so we need these models to explain to us why they're making their decisions. But another reason is just that, well, explaining the model can help us make better models. So as data scientists, we want to build the best model that we can. And often within the model building process, if we can have an explainable component to this, then that helps us make better models. Okay, so explainable AI is important for consequential decisions. Let's look at the context that we're doing this here. So we partner with a major development bank who asked us to predict whether sovereign guaranteed investment loans would be delayed. So these are like big infrastructure loans that are millions of dollars. And a lot of these are delayed for reasons that you can imagine why a big infrastructure project would be delayed. And so an example of one of those projects is the modernization of the Salto Grande Bination hydropower complex. And this is this is a dam that's on the border between Argentina and Uruguay. And this was an $80 million project. These are the types of predictions that we're looking to make whether a project like this is going to be delayed. So it's certainly a consequential decision. And if we can get the model to explain to us why it made the decision, maybe people will understand it more and trust it more. In terms of what explainable AI exists, there's you can kind of break this down into explainable AI that looks at global feature importance and marginal effects. So these are things like partial dependence plots that are essentially numerical derivative methods that look at how the predictions change around the values of certain variables. Global feature importance looks at, well, what if we exclude this variable from the model? How much does the model fit change? On the other side of things, there's explaining individual predictions. So Lime and Shapley values are really popular. And there's very good implementation for this stuff in R. So there's a Daleks package, FastShap package, PDP and Lime packages. And just to channel a little bit of Gelman right here, another solution to this maybe is just not to use such complicated models. So why are you estimating 1,000 decision trees when maybe a single decision tree that has restrictions on the complicatedness of its decisions? If you can fit a model into a paragraph, like maybe you should use that if the performance is no worse than a very complicated model. So there's, if you're curious, I think if I had to do this again, I would probably do something that was just a much more simple model that was still built using machine learning, but just restricted in terms of doing very simple things. And if you're curious, there's a really nice package called Corals that restricts to these very simple decisions. And no surprise, Andrew Gelman was right. Really nice dashboards. That's kind of how things are trending towards. There's this Shapash dashboard that is in Python that presents all of these explainable AI things all at once. So you get your local explanations, you get your feature importance. You can drill down by different observations. The Google What If tool is really popular as well. It's nice because it does all those things, but allows you to figure out another data point that's really similar, except varies in that one variable that you want to see the counterfactual for. So those are the tools that exist. I don't know of a comparable dashboard within R that. So if people know of this, I know I'd love to hear from them. We were restricted to using Tableau because the institution we were working with really wanted us to implement it in Tableau. So we just built a series of Tableau dashboards ourselves. All right, so let's talk about the implementation and the survey that we're going to run in order to understand the impact of explainable AI. The organization we worked with was very kind and let us do a survey for 685 team members. We ran this from May to June, and we got a very good response rate. We had a control group that we gave just the predictions and the confidence intervals for those. So we presented them with, okay, here's your project. Here's what we think. Here's the model says that it's going to be delayed. We also provided confidence intervals around that, which we think was really important. This is not like a real control group because they're still getting the predictions, but we were worried about issues of power and also the organization. They wanted us to promote this model, so they didn't want us to give one control group that didn't get any predictions. The explainable treatment, they got 2 extra screens. So what they saw were information on model performance. So we gave them predicted true plots, as well as some just statistics about the model. And we also gave them model explanations in terms of these charts that describe exactly for a particular project what contributes to the prediction. And so these are really nice Shapley plots. And we embedded these within a Tableau dashboard. The general structure of the experiment was we surveyed a manager about what they expected the delay to be. Then we show them these different screens, and then we looked at whether they updated their prediction guess. We focused on 4 different outcomes. The first one was whether they self-report that the machine learning tool is useful. The second one was whether they understood the machine learning tool. And then we looked at whether they actually changed the delay estimate before and after viewing the tool. And then we looked at the absolute value of that change in delay estimate. There were 5 moderators that we thought might have an impact. One was definitely the explainable treatment, their role, like whether they're senior or junior, the total amount of the loan, and then there were like self-reported machine learning familiarity. All right, so from here to analyze the data, we have 3 different types of variables: order logistic, Poisson logistic, and this is going to take. We don't have so many observations here, and I was immediately worried about ending up on Andrew Gelman's blog as like, why did you p-hack this result? And so like anyone here, I think that my first resource was to go to Twitter. So I asked out. I said, what are some good rstats packages for doing this types of, in particular, ordinal model multinomial regressions are not something that I had used in a while. And our fearless leader said, in so many short words, one word, in fact, he just said rstanarm, and then for some reason put an asterisk there. I mean, what a Jedi master. I have to give a consolation prize to my other friends, Grant McDermott and Jim Savage, who replied, gave me some great advice. One of my friends just said, just do a linear model. Thank you, Jesse. Jesse's a professor at Brown. Thanks for that. But Jared's right. I mean, it turns out that Jared was led me in the right way. But I sort of knew that was the right way. And I want to dig into this Bayesian cringe that Andrew Gelman talked about. So why was I resistant for going Bayes? I think a big reason for this was the idea that, well, I'm writing a research paper. I'm going to have to send it to a journal. I'm already doing machine learning stuff. Like, the referees, how are they going to interpret this Bayes thing that I'm doing? So I was worried about being judged by them just for doing something that was different. I mean, this is research. You should be doing something that pushes things forward. But in my mind, I was worried about how referees would believe this. I think there's something else, which is that I've taken classes in Bayes. I've taught a class in Bayes. I still like when I have to construct my priors, I always kind of pause and I say, well, how informative should they be? How flat should they be? And it just, maybe that's the cringe. Is like, I sort of like seize up at that point. I'm like, I really don't kind of know what to do at this point. And I'm really afraid of being wrong. I mean, it's nice that Gelman gave us an out and said, like, look, you can be wrong. Just like put yourself out there and then learn. And then, there's also, back when I learned Bayes, I learned it in JAGS. It's really, the syntax wasn't great. And I was just, we tend to use the tools that we know a lot and we've used a lot. And, I hadn't dug into Bayes in 5 years. And so I was worried about stepping forward with that. Of course, there was just like plain laziness, right? Why do something more complicated than it needs to be? And then, of course, our friend Bayesian cringe. Okay, so I'm happy to say that all these fears were unfounded. I sort of knew this was the right way to go forward, and I finally did the dive into all the stuff that had happened in the Stan world. I had to channel inside of myself. I knew that there was like an R superhero, and I had to channel that. So I just calmly meditated on that. And I imagined like pulling this inner Andrew Gelman for myself. And then I just, I dived into everything, and I didn't need any of that. It was, all the tools were super easy. rstanarm is fantastic. I think it helped out someone like me who was working with models that I hadn't specified priors for before. The validation tools are fantastic. Tidy Bayes is fantastic. I thought it was going to be much harder than it was, and it wasn't. And I just have to give such so much thanks for the people who work on these tools. Thanks for making our lives so much easier. So I encourage everybody who's thinking about going into Bayesian methods looking at this. Okay, so let's go back to our case. Let's look at how much explainable AI impacts whether somebody is going to update their delay estimate. So how much is this going to affect trust in machine learning? So we're estimating a Poisson model about how much in absolute value somebody updated the delay estimate. And we're just going to estimate just that coefficient on the treatment group, so whether they're in the explainable AI treatment. And it looks like the coefficient is centered around 1.1, meaning that there's like about a 10% increase in how much somebody updates their delay estimate. Now, the average delay update is only about 2.2 months, so this is this is a sizable impact. I think things get interesting here when we start to include all the other moderators that we thought might have a role. Now, notice that after controlling for all the others individual characteristics, a treatment effect is mixed, which is fine. This is the data these are the posterior that's consistent with the data in the prior, and I'm perfectly fine with that. We're not hunting around for a certain p-value. One thing that was surprising here is that a higher loan amount means you're more likely to update your beliefs, which is not something that I think we thought the direction would be reversed. Something that we didn't expect that we found that was really striking is that the most senior members of the team are the ones who appear to trust the AI predictions the least. This was really strong across all these different specifications. This makes sense because the person who's in the more senior role, might have dived into more of the project, might have more of their own career, brought up in terms of understanding that particular project. And so they have more to lose from trusting a model. We can also estimate the logistic model about whether after they viewed the machine learning tool, if they updated their delay estimate. And what we find are, again, kind of mixed impact of the explainability treatment, which is perfectly fine. We do see that people who self-report as having more machine learning knowledge tend to update their delay estimate, much greater. Again, we see this negative impact of having more senior roles. And these senior roles are way less likely to update their delay estimate. For self-reported usefulness, we do see this impact of the treatment group. So the explainable AI makes people think that the prediction exercise itself is more useful. And then, of course, higher machine learning familiarity leads people to believe that the machine learning tool is more useful as well. And again, this manager closeness effect we tend to find. I think things get really interesting once we start to look at heterogeneous treatment effects. So we're basically interacting this treatment group with these individual characteristics, and we find these really, really strong effects about the people who are least likely to trust AI initially. If they happen to be in the explainable AI treatment group, they're much more likely to update their belief. And these point estimates are really large. So the chief of operations and those who self-report no familiarity with machine learning, they're people who seem to not trust the AI predictions. But if they happen to get this explainable AI treatment, then it seems like they trust them quite a bit. And I think that's a really, really nice result. It tells us why are we making this explainable AI? It seems like we're making it for the people to build the models, but we're also making it to bring in people who don't have so much experience in artificial intelligence or machine learning and help them understand what's going on. And it seems like that has a very large effect. Okay, so to conclude, we find that these explainable AI models actually seem to increase belief updating. It seems like they increase perceived usefulness, decrease understanding of the model. Larger loans are more likely to update their beliefs. And then senior members and those with least ML familiarity are least likely to trust AI. But if they get this explainable AI model, then they greatly increase their trust of AI. So to go back to this our God that I was trying to channel. Like, who is this Cape Crusader? Was it someone inside me the whole time? No, of course not. It was Jared Lander. I was channeling Jared Lander, and I have to thank him so much for showing me the way. Of course, I also have to thank Fiverr artist Nurul Anwar, because I'm not a very good artist, but he was able to turn around this piece of artwork in 24 hours. So thank you. And the last thing I would want for anyone to do here is to go to this link and download all of these wonderful backgrounds. I mean, include them in your backgrounds. Dan, could you make an action figure? I mean, I would hold this. I mean, Jared, I've got to say, you've been working out in the gym. I mean, this is incredible. Yeah, just great. Okay, so that's my talk. If you have questions or comments, you can reach out to Selina or I. Thank you so much. And again, thanks for everyone who's making these wonderful tools. Really appreciate it.
Thanks, John.
Thanks, everyone.
See you. So speaking of the Stan workshop,